chordates descended from ancestral chordates, early Cambrian chordates and all the features that we share.
Some of the most important advances of the primitive chordates included a notochord, a support rod which ran down the back and allowed these primitive chordates to swim in an S-shaped motion. A post-anal tail, a tail region which is full of muscle rather than intestine and can be used in propulsion. And a set of pharyngeal slits with a rich blood supply which can function as gills and thus provide additional oxygen. These are incredibly important features that developed in the first chordates, which the fish would require. But they are seen in humans as well, not in human adults, but rather in human embryos. Human embryos possess a throat or a pharynx with slits and branches of the aorta traveling to each slit, just as in these chordates. Embryonic humans possessed a tail, which will be lost during development. Embryonic humans possess a notochord, which does not exist in adults. But nevertheless, these are features which all chordates share, even though some chordates, such as humans, do not possess them as adults, but rather only as embryos.
There are a number of features which primitive chordates share in their cardiovascular system with advanced vertebrates, such as cardinal veins and all of the proteins used in the vertebrate clotting cascade, even though these chordates do not clot their blood using these proteins. However, perhaps the most significant is from the ventral heart, a ventral aorta then sends branches to the gills, and it forms a series of aortic arches which obtain oxygen and then drain into the dorsal aorta, which distributes this oxygenated blood throughout the body. This is the setup which allowed the fish to have gills providing increased oxygen for an increasingly active lifestyle, functioning as their respiratory system. So the gills found in fish first developed in invertebrate chordates.